So I just want to look at quadratic equations graphed a little bit more in detail than I did in the first part. So here I have three quadratics graphed, and each one you can see they're just shifted down. They have the same shape actually, but they're just shifted a little bit. And quadratic 1, this is Q1 right here. This will be Q2, and this will be Q3. So this is the equation for Q1, and the discriminant you can see we have A, B, and C. A is -1, B is 2, C is 1. The discriminant is going to be B squared, so 2 squared, minus 4 times A. A is -1, and C is 1. So we get 4 minus, it's going to be plus 4, 8. And this is greater than 0, so that means we should have two real solutions, which you can see here on the graph as the x-intercepts. And there's two of them because it crosses it twice, of course. And the actual solution, of course, we can use the quadratic formula. We could also try the factoring strategy. In this case, I don't think it'll give us anything nice, but let's just use the quadratic formula here. Negative b is -2 plus or minus the square root of b squared. B squared minus 4ac, we already calculated that. That's just 8. Over 2 times a, 2 times a. -2 plus or minus, this reduces down into 2 root 2. 4 is in there, 4 times 2, the square root of 4 is 2, so 2 root 2. All over -2, and that's going to give us, I can reduce everything by 2. I can also multiply everything by -2. That's going to end up changing this to minus plus, but that doesn't really matter. This will change to a plus here, so plus, plus, and these flip, but they're both there, so there's no reason to change that. And I can divide everything by 2. So I get 1 plus or minus root 2. And so that's what these two solutions are. Okay, now for the middle blue graph, you can see we shifted it down to where it's now -1 instead of +1 here for C. That's all I've changed. What that does is it shifts this thing down 2 units. And this was on 1, 2 here. It gets shifted down 2 units, and now it's going to be directly on the x-axis. And that is a single point of intersection on the x-axis. So where this thing equals 0, it will only be at 1 point, so it should have only one solution. Let's test that with the discriminant, right? A, B, and C. C is now -1. So B squared minus 4 times A times C. It's going to be 4. This is going to be -4. Gives us 0. And doing the quadratic formula, -b plus or minus the square root of the discriminant, which is just 0, over 2 times A. -2 plus or minus 0 is just 0, so no reason to write that, over -2. And we get +1, which that one we can see on the graph, right? +1 is right here, x equal to 1. Okay, finally, if we shift it down 2 more units, it's going to be a -3 for C instead for Q3. And you can see that this does not cross the x-axis at all. So we should expect there to be 2 complex solutions for this third one. The discriminant, we're going to have b squared minus 4 times A times C. Gives me 4. This is going to be -12 or -8. Okay, now the solution. So this, of course, is less than 0. We expect 2 complex solutions. The actual solution of this is going to be -b plus or minus the discriminant, or the square root of the discriminant, all over 2 times A. -2 plus or minus. This is going to be 2 root 2 I over -2. And once again, I can simplify plus, these flip, but it's the same thing. Reduce everything by 2. 1 plus or minus root 2 I. 2 complex solutions from that one. Now, linear equations either had no solution, one solution, or infinitely many solutions. And that based purely depending on where the line was, right? If the line was in line with the x-axis, above it, or it crossed it in some angle. Here, the quadratic solutions depend purely on if and how the graph intersects the x-axis. There's always going to be 0, 1, or 2 solutions, never infinite, and then never anything besides those 3 possibilities. So note that we make the function equal to 0 for this technique, just like we do for the quadratic formula. In all of these cases, the main thing is that you must make each quadratic equal to 0. That's what I did. I just didn't write it down. This thing equals 0 when the quadratic equation is true. And this one also equals 0. You solve this equation by plugging into the quadratic formula, and that gives you your x-intercepts. That's the idea here. All right, try it out in number 2.